Hey guys, so this lesson is on something called law of sines and law of cosines. It's used when you have a triangle that's not a right triangle and you're trying to find missing sides or angles. So depending on what sides or angles you are given, that will determine which law you use, law of sines or law of cosines. So we're going to start with law of sines first. I'm going to go through a few examples and then we'll do some with law of cosines. Okay, so for law of sines, basically first let me explain this box. So when it says sine of A, capital A, over lowercase a, what that means is they're saying, like, if we were to say that these three sides were capital A, capital B, and capital C, the sides opposite them are the lowercase a. So like this one would be lowercase a. This one would be lowercase b. This one would be lowercase c. So they're saying sine of A over A. So that would mean that it would be sine of A over A equals sine of B over B equals sine of C over C. Now, even though this is listed 3 times, you would never use all 3 of them when you're solving. It would just be 2. The reason why this is listed, all 3 of them like this, is because it's just saying it's true for every angle. Okay, so there are 2 scenarios when you would use law of sines. The first one is if you are given 2 angles and a side opposite one of those angles. So 2 angles and a side. It's supposed to be a G. My stylus isn't doing very well tonight. So 2 angles and a side opposite one of those angles. Another scenario is if you were given 2 sides and an angle opposite one of those sides. Okay, so that's when you would use law of sines. So let's do a few examples. Okay, so notice on this one, you are given 2 sides and an angle opposite one of those sides. And you're asked to find the angle opposite the other side that you're given. So that's how you know you're going to use law of sines. And so you would just set it up. So it's going to be sine of 42 over 22, because that's opposite the 42-degree angle, equals sine of x over 12. And that's because the 12 is opposite the x. So now to solve, the easiest way to do it is just to cross multiply. So this turns into, let me move this up a little bit. So this turns into 12 times sine of 42 equals 22 times sine of x. And so here's where you're going to get your, well, actually, you know what? We're going to wait for the calculator. We could, I guess, if you wanted to, you could do 12 times sine of 42, but instead I'm going to move this 22 over. So think about if we're trying to solve for x here, we need to isolate sine of x. And at the very end, since we're finding an angle, we would use an inverse. So I'm going to first divide both sides by 22. And then that way I can just put this whole thing in the calculator and then do the inverse of that. Oops, sorry. Okay, so now in the calculator, you're going to do 12 times sine of 42. Now remember, if you're doing this in a phone calculator, you kind of have to do it backwards. So you would hit 42 sine times 12 equals. And then you're going to divide that by 22. So right here, you should get approximately 0.365, I guess we can call it. And now remember, to get the final answer, you're going to do the inverse. So you're really plugging in inverse sine 0.365. If you are using a phone calculator, keep that decimal in your phone right now, and then just hit second sine, and it'll give you the answer, which is 21.4 degrees. I just realized after I did this problem, and I'm sorry about this, that this was not the first example. It was the second one. When I uploaded the notes into this program, it moved everything over. I don't know why. Okay, sorry about that. That was example 2. I meant to do 1 first, sorry. But the answer to that one is 21.4. So you cross multiply, and then you have to do an inverse. I intended to do this one first. Okay, so this one says find AB. So AB is going to be our X. And then notice that these two are opposite each other and these two are opposite each other. That's what you need in order to do law of sines. Okay, so once you determine its law of sines, then you set it up. So it's going to be sine of 53 over X equals sine of 44 over 7. Okay, so again, you want to cross multiply. So you're going to have X times sine of 44 equals 7 times sine of 53. Okay, again, you can leave this like that for now because now we're going to divide both sides by sine of 44 to get X all by itself. And then you'll just put it all in the calculator at the end. Okay, so now in your calculator, you're going to do sine of 53 times 7, which is about 5.59, and then you're going to just hit divided by sine of 44. So you should get here that X is approximately 8.05. Okay, so there is example 1. Now, again, I guess I should say if you're doing that part in your calculator, you would hit 53 sine times 7 equals, and then divided by 44 sine equals. Let me just double check that. So 53 sine times 7 equals, divided by 44 sine equals, 8.05. Okay, so that's example 1. Example 3 is asking us to solve the entire triangle. So basically, in order to do this, you would do law of sines twice. Basically, you can find this missing angle, angle B right here, by adding 58 and 93 and subtracting from 180. So we get that B is 29. Okay, and then you can make like this X and this Y. So then you would just set it up. So you're going to do you want to do one equation for X and one equation for Y. Do not put one equation with X and Y in it. That's too messy. One for X, one for Y. So like the one for X is going to have, you're going to have 93 and then 16 and 29. So it's going to be sine of 93 over x equals sine of 29 over 16. Cross multiply, so you end up with x times sine of 29 equals 16 times sine of 93. Oops, forgot the 9. Divide both sides by sine of 29. So then again, you're going to put that on your calculator, and you end up with 32.96. Okay, why don't you guys try y? I'm just going to write here that y, you should end up getting 27, or approximately, I guess I should say 27.99. If you don't end up getting that, let me know. Shoot me an email. I can help you figure out what you did wrong. But just to save this, and so it's not like an hour-long video, there's y. So again, you would set up another equation. So you would have sine of 58 over y equals sine of 29 over 16. Then you'd cross multiply. Okay, so you guys give that a try. Again, let me know if you have any questions about that. Okay, so next we're going to do law of cosines. Law of cosines is another way that you can find missing sides or angles of triangles that are not right triangles. So remember that right triangles is when you would use a trig ratio like SOHCAHTOA, but you do not use SOHCAHTOA on these because they're not right triangles. So this one looks a lot more complicated than it actually is. I mean, it's a little bit more work, a little more plugging in, a little more room for error because there's a lot of algebra involved. But again, this is only listed 3 times here. It's really the same equation, but just like they're saying that it works for angle A, and it works for angle B, and it works for angle C. So they're just saying that it works for all 3 of them. So again, they're saying like capital A is the angle, and then the lowercase a represents the side opposite that angle. Then we have capital B is the angle, and then lowercase b is the side opposite that angle. And then capital C is the angle, and lowercase c is the side opposite that. So the main thing that is true about law of cosines, and this is what you need to remember, is the angle that's here in the equation is the angle opposite the side that's on the left. So whatever angle you're choosing or where you have to use in this spot, the capital letters, the side opposite that angle will always be on the left side of the equation. So I will write that. I will write that out for you over here. Oh my gosh, why does it keep going back to that? I will write this out for you as like a little note here. So this right here, I'm going to write it over here. We will say it's the side opposite given angle. So if you're given the angle, the side opposite that always goes on the left. Always, always, always. So law of cosines is used in 2 scenarios. If you are given the measures of 2 sides and the included angle. And then you'd be asked to find like the side opposite that. Sometimes it's referred to as side angle side. Like if you have side angle side, that's when you know you're doing law of cosines. And then the other scenario is if you're just given 3 sides and you're asked to find an angle, that would also be law of cosines. So if you want to think of it, that would be like side, side, side. We have all the sides. Okay, so those are the 2 scenarios where you would use law of cosines. So now, again, I have 3 examples that we're going to do. Okay, here's our first one. We're going to find AB. So again, we're going to make AB x. Oops. Okay, so notice that x is opposite of the 41, right? So that means x is going to go on the left side of the equation. So if you look back at your notes and look at the left side of the equation is a side squared. So this is going to be x squared. Why is this not working? Oh boy. Okay, x squared equals. The next thing that you'll see in the equation, I'm just going to use the top one, how it says a squared equals b squared, c squared, whatever. Or you know what? I guess I'll use the c one. So it's c squared, this is like your c, equals a squared plus b squared. So this would be a squared, this would be a, and this would be b. So you're going to set up, if you follow the equation, it's a squared plus b squared. So it's going to be 29 squared plus 13 squared minus 2 times a times b times cosine of c. So 2 times a, which is 29, times b, which is 13, I'm running out of room, times cosine of c, which is 41. Sorry about this. Okay. So that's the initial setup. So you have, this is like your c squared. Then you have a squared plus b squared minus 2ab times cosine of 41. So this whole thing is like attached, all that multiplication, and then you have your addition. So when you're solving here, you really just have to use order of operations. So this x squared, obviously nothing's happening with that. So you can do the 29 squared and the 13 squared first, as you want to do exponent. So 29 squared is 841 plus 13 squared is 169. And then it's minus 2 times 29 times 13 times cosine of 41. Now you can either put that in the calculator as make this plus and put in a negative 2, or I usually just leave it as negative. And then in my calculator, I'm just punching in 2 times 29 times 13 times cosine of 41, which is 569.05, and it's positive in my calculator. So I'm going to put 569.05. I say it's positive because sometimes when you plug this part in, it'll be negative, and then you'll have a negative and a negative, and that becomes positive. So just really pay attention to your signs. That's sometimes where kids make mistakes. Okay, so now we're just going to go left to right, and you're going to do in your calculator 841 plus 169, which is 1010, and then you're going to do minus 569.05. Don't forget the 0.05. So now I have x squared equals 440.95. Okay, and then lastly, we just have to take the square root of both sides, and then we are done. Oops. Okay, so now the square root of 440.95 is 20.9988. So I think we could probably say that's 21. We're safe to say that's 21. Okay, so a little bit trickier. So you just want to plug it all in and just be really, really careful with your algebra. You want to make sure that you're doing order of operations properly. Okay, so we're going to come over here to example 5. I'm going to have to erase all of this. Okay, so example 5 is one where you are just given all sides and you're asked to find angle B. So that means angle B is your x. So this is set up the same way with the exception that the 17 now is going on the left. Think of your 17 as like your B think of this as your little c and this is your little a. So this has to go on the left-hand side because this is the angle we're trying to find. So like these two go together. This is the angle that goes all the way to the right on the equation, and this goes all the way to the left, the 17. So let's plug it in. So it's going to be 17 squared equals, so that's b squared equals now a squared plus c squared. So it's going to be 10 squared plus 11 squared minus 2 times a times c, which is 2 times 10 times 11 times cosine of x, because that's the angle this time. Okay, so again, you're going to want to do your exponents first. So 17 squared is 289. 10 squared is 100. 11 squared is 121. And then you can do this part right here. So minus 2 times 10 times 11 is 220. And then cosine of x. Now, probably the biggest mistake that kids make here at this point is it's very tempting to just go across and do 100 plus 121 minus 220. That's illegal algebra. And the reason why is because this 220 is attached to the cosine of x. That's the coefficient of cosine of x. So these have to stick together. You cannot just like subtract across here. So that does not work. Get rid of these lines. What you do want to do is you're going to do 100 plus 121, which is 221. So you're going to have this is 221 minus 220 cosine of x. And then you're going to have the 289 over here. Okay, so let's think about what we would do next for order of operations. Again, these are attached. So the only thing you can do is we can move the 221 over. So we're going to subtract 221. Okay, so then 289 minus 221 is going to be 68 equals, now here's another place where kids will often make a mistake. This was a negative 220 cosine of x. So we're going to bring down that negative 220 cosine of x. Okay, so almost done. Our next thing that we want to do is we have to get the cosine of x isolated. That way at the very end, we can do an inverse cosine. So we're going to divide both sides by negative 220. I'm going to move this up a little bit. Okay, so now we have on the left side, 68 divided by negative 220 is about negative 0.3091. You want to leave that in your calculator. So I'm going to put that in my calculator. Okay, so I have negative 0.039. It's really 30909, like repeating. So just leave that decimal in your calculator. And this is equal to the cosine of x. So now remember, to solve, you just have to do the inverse. So in your calculator, you're doing inverse cosine and then negative 0.3091. But I'm leaving that decimal in my calculator. So say you're using a phone calculator, you would just leave that decimal in there and hit second cosine, and then it's just going to give you the answer, which is 108.004. So I think that's safe to say that x is approximately 108. Okay, so that's when, this is probably the harder one, is when you have to solve for an angle. And it's only harder, I think, because there's a lot of algebra and like a lot of spots where you could go wrong. Okay, so that's example 2. Example 6, we're going to do next. This one is finding everything, find all the missing parts. And then that's it. So we have solved the triangle here. We are given the 105, the 27, and the 22. So Remember, if you're given two sides with an angle between them, that's sort of like side angle side, your only option here is law of cosines. So we have to find AB first. Why don't you guys actually pause the video and take a minute and try to find X? So what X ends up being is 38.99. And this is the setup if you didn't get that. So notice that the 105 and the X are opposite each other. Let me move this up a little bit. The 105 and the X are opposite each other. So that means the X goes on the left. So it would be X squared equals, and then it's the other two sides. So 27 squared plus 22 squared minus 2 times those two, 27 times 22 times cosine of 105. So remember, you would do order operations. It ends up being you have X squared equals 1520.47. Now, again, if you're not getting this, just let me know and I can do out every single step for you. You just email me. So that's where we're getting 38.99. Okay, so now that we have 38.99 for this side, now our options are kind of open. Like, you wouldn't really want to do, like, look at what we have now. We have the three sides, we have one angle. So technically, when you have three sides, you could do law of cosines again and find like A or B. But law of cosines is really long, and it's not really necessary to do that right now. Instead, what you could do is you could do law of sines, because law of sines is nice and quick and easy. So see how like these two are across from each other, and say like A and 22 are across from each other. So I could find A right now by doing law of sines. Once I have A, then I can just subtract from 180. So once you get that initial side, it kind of like opens the door to more options for you. Okay, so I'm going to do law of sines now. Do it down here. So for law of sines, remember, if I'm going to say that this is my y, actually, let me get rid of these little lines inside. If A is y, it's going to be sine of y over 22 equals sine of 105 over 38.99. Okay, and then we're going to cross multiply. Let me move this up. So that's going to be sine of y times 38.99 equals 22 times sine of 105. Remember, we're trying to isolate the sine of y right here, so you want to divide both sides by 38.99. Okay. So now I have sine of y equals, and you're going to do 22 times sine of 105, which is 21.25, and then we're going to divide by 38.99, which is about 0.545. Now we have to do inverse. Okay, so it's about 33.02 degrees. So that's the measure of angle A. Let me do a little separation line here. Okay, so there's angle A. Then all of that is for AB. Oops. And then lastly, to find the measure of angle B, you're just going to add 105 and 33.02. I mean, if you wanted to call that 33, like that's fine. So 105 plus 33.02 is 138.02, and then you're going to subtract from 180. So you end up getting 41.98 approximately. And again, if you called it 42, whoops. If you called it 42, that's totally fine. Okay, so that's how you would solve the entire triangle. For now, I just wanted to go over these just so you would have them. But for now, the practice I'm going to have you do is just finding like one part. I do want to say too that if this is still like really confusing for you, like try a few. I'll post the answer key too, so you can see what the answers are and check as you go. And then if you need some help, you can come on to the live help session. Okay, so that's that. Law of sines, law of cosines, again, used to find missing sides and angles of triangles that are not right triangles. Please email me, let me know if you need some help. All right, have a good day.